Hi, today we're back with part 2 of OWASP Top 10 2021 edition. We'll be talking about the number 6, 7, 8, 9, and 10 on this list. And we'll start with vulnerable and outdated components. So sometimes we find out that the company that we are pen testing or working for is using a program that has a well-known vulnerability. How do we end up having this type of vulnerability? It's generally speaking if we don't know the versions of all the components that are being used, or using vulnerable, unsupported, or out-of-date software, not fixing or upgrading the underlying platforms, frameworks, and dependencies in a risk-based and timely fashion, and so on and so forth. So we end up with CWE 937, which was OWASP Top 10 in the 2013 edition, or the one that is numbered 1035, that is in the OWASP Top 10 A9 from the 2017 edition, which is also using components with known vulnerabilities. The use of unmaintained third-party component, which is the CWE 1104. So let's take an example. Let's say a company has WordPress and it hasn't updated the version of WordPress for a few years. We could use WP scan and find that the version that is used is the 4.6. Just searching for WordPress 4.6 will reveal that it is vulnerable to unauthenticated RCE exploit, or remote code execution. And we can even find the exploit on ExploitDB. This shows how easy it is for an attacker to exploit this type of vulnerability. And the thing is, if a company misses just one single update for a program they use, it could be vulnerable to any number of attacks. So let's talk about how we would do it in practice. So this is about known vulnerabilities, which means most of the work has already been done for us. Our job is just to find out the information for the software that is being used and research to find an exploit. So let's go through that with an example of a web application, which is this one, Nostromo 1.9.6. So what do we know about this? So we know that the software that is being used is Nostromo 1.9.6, and so we can search for an exploit using for example, ExploitDB. And so when we go to ExploitDB, we end up and search for Nostromo 1.9.6, we end up with these results. And you can see that the first one is a remote code execution, which is awesome. After downloading it, when we try to execute it, we end up with this error. Name, CVE 2019, 116, etc. is not defined. And you get in line 10, this isn't defined. So when we open the code, we end up with this, and we see here that this doesn't exist. So what we can do is we just need to put this into a comment. So we just need to comment this line. Once this is commented, we can execute the exploit and we get an RCE. So most scripts will tell you what arguments you need to provide. So for example, in this, they tell you it's the target IP, the target port, and the command that you want to execute. So generally speaking, exploit developers will rarely make you read hundreds of lines of code just to figure out how to use the script. However, it's not always this easy every time. So sometimes you will just be given a version number, and other times you may need to dig through the HTML source or even take a lucky guess on an exploit script. So the good thing about vulnerable and outdated components is that the work is already done for us. So we just need to do some basic research and make a few changes, and you're done. So for this practice, we are asked to go to a web page where we find a vulnerable application, and all the information we need to exploit it can be found online. And then to get the flag. So let's open the website. So what we can see here is welcome to online CSE bookstore. This site has been made using PHP with MySQL. The layout used Bootstrap to make it more responsive. It's just a simple web. Anyway, we see that it's called online bookstore. Let's go to ExploitDB and search for online bookstore. As simple as that. And there's this one. Let's see. So when we search for online bookstore, there's this one, which is an unauthenticated remote code execution. Awesome. Let's open it. And we get this this exploit. So what is the vendor homepage? The version, it's the version 1.0, and so on and so forth. Anyway, so we can just download it, but as you can see here, it's also, we already have like the ID number. So instead of using ExploitDB, we can also use the command line search exploit. So I'm gonna do it that way too. So search exploit, and then the name that you want to search for here, it's online bookstore. And we have the same things, an authenticated remote code execution, which is here, PHP web apps / and the number 47887.py. Great. So what we can do is using it. So I'm using Kali Linux, just so you know. And the results from such exploits are here in this on this path. USR share ExploitDB exploits, then the rest of the path that we found on search exploit here, PHP web apps 47887.py. So let's just use it like this. It says it misses the argument URL, or I could just put -h, and it says we need the argument URL, and this is the URL of the target. So let's put the URL of the target, which is http 10.10 10.8.84. And do you wish to launch the shell? Yes, I do. And here we go. So now the question is, what is the content of the file that is in opt/flag.txt? So we can just use cat flag.txt, and this is it. And here you go. So the next one in this list is identification and authentication failures. So authentication and session management are core component of modern web applications. And authentication allows users to gain access to web applications by verifying their identities. So without verifying their identities, we can't allow users to get somewhere. So the most common form of authentication is using a username and password mechanism like this. So if a user wanted to access their account, they would send their credentials to the website or to the server. And then the server, after verifying the credentials, will send session cookies. So these session cookies are needed because web servers use HTTP and HTTPS, which are stateless protocols. So having session cookies means that the server will know who is sending what data, and then the server can keep track of the user's actions. So if a flow is found in the authentication mechanism, the attacker can gain access to other users' accounts, and then accessing also sensitive data. So common flaws in authentication mechanism include brute force attacks. So if a web application uses usernames and passwords, an attacker can try to launch a brute force attack that would allow them to guess the username and password using multiple authentication attempts. Using weak credentials, so sometimes web application doesn't set strong password policies, and if the application allows users to set passwords such as password 123 or QWERTY or common passwords, an attacker can easily guess them and access user accounts. We have also weak session cookies. So as I said just before, session cookies are how the server keeps track of users, and if session cookies contain predictable values, the attackers can set their own session cookies and access users' account. So there are multiple ways of mitigating this for broken authentication mechanism depending on the exact flow, like enforcing a strong password policy to avoid password guessing, or enforcing automatic lockout to avoid brute forcing. So for example, after 3 attempts that are wrong, they could automatically lock out the account. That would prevent the attacker from launching more brute force attacks. And implementing multi-factor authentication. So if a user has multiple authentication methods, apart from, for example, a username and password, and also receiving a code on their mobile device, then that would be 2 different type of authentication factors, which will make it more difficult for an attacker to get both the password and the code to access the account. So the mapped common weakness enumeration here are improper validation of certificate with host mismatch, improper authentication, session fixation, and so on and so forth. An example of identification and authentication failures is one that has a logic flow. So one of them is the re-registration problem. So the re-registration problem is a logic flow in the authentication mechanism. So let's say there is an existing user named admin. So we want to access this account. So because we don't know the password, what we could do is try to re-register the username with a slight modification. Here, you'd have a space, like notice that there is a space before the word admin. And it will register a new user, but that user will have the same right as the admin account, the original one. So now when you enter that in the username field and enter other required information like email, ID, or password, and we submit the data, it will register a new user, and that new user will also be able to see all the content presented under the original user admin. So let's see this into action with this time the username Darren, and then try it again with the accounts of Arthur. So here what we could do is try Darren. We don't know the password, so I'm just gonna put whatever and try to sign in. No, invalid username or password. But let's try to register with the username therein. And it says this user is already registered. So I'm gonna change it slightly by adding a space, as you can see here. So there is a space before. And see if I can create it. User registered successfully. So let's sorry. And here we go. Now we try to do the same thing, but with Arthur. So we log out and register. I'm adding the space here. I was able to register. I forgot to put the space before, so now, as you can see, there is the space in the username. And here we have it. So the next one on this list is software and data integrity failure. Firstly, what is integrity? So integrity refers to accuracy of data, completeness of data. In general, it is important. So integrity is important as we want to be sure that important data is free from unwanted or malicious modifications. And integrity involves maintaining consistency, trustworthiness of data over its entire life cycle. So data must not be changed in transit, and precautionary steps must be taken to ensure that data cannot be altered by unauthorized people. So for example, let's say you download the latest installer for an application. We want to be sure that it wasn't modified or damaged in transit. And how to do so? We, generally speaking, use hashes. So a hash is a number resulting from applying a specific algorithm that we call a hash algorithm over a piece of data. So some hashing algorithms that are known are, for example, MD5, SHA1, SHA256, and so on and so forth. So let's take WinSCP, which is a free FTP and SFTP client for Windows. So to check this file's integrity, if you wanted to download it, you can go to SourceForge, the repository of it, and for each available file to download, there are hashes published. So for example, you get here, this is the release note, and as you can see, each file that can be downloaded, there are the hashes for it. MD5, SHA1, or SHA256 for each of them. So if we wanted to, so we would get the hash for the file we download, and then calculate the hash of the downloaded file and compare with the hash that was pre-calculated by the creators of WinSCP. So if I downloaded the WinSCP 5.21.5 setup.exe, we would calculate the hashes using Linux. Those are the commands that we can use. So MD5 sum for the MD5, or SHA1 sum to have the SHA result, or SHA256 sum to have the SHA256 one. Then once we calculated these three hashes using the downloaded file, we can compare with the one that comes from the SourceForge repository. And by comparing, we can see that they match. So great, it's an exact copy. No problem with its integrity. So to prevent software and data integrity failures, we can use security controls designed to maintain the integrity of the information, like digital signatures, version control, process for code review and configuration changes, user access controls, and so on and so forth. Now, why do we end up with these types of failures? This vulnerability arises from code or infrastructure that uses software or data without using any kind of integrity checks. And since no integrity in verification is being done, an attacker might modify the software or data passed to the application, and the results are unexpected consequences, depending on what the attacker have put in it. So there are mainly two types of vulnerabilities in this category: software integrity failures and data integrity failures. And the mapped CWE here are inclusion of functionality from untrusted control sphere, download of code without integrity check, deserialization of untrusted data, and many others. So for software integrity failures, let's say that we have a website and this website uses third-party libraries, and they are stored, instead of being in our own servers, they are stored in an external out-of-control server. So this sounds a bit weird, but it's something that is commonly used. For example, jQuery. It's a JavaScript library. If we want to include this library, we can do it in two ways: either having it on our servers or directly including it from their servers without downloading it. And we can do that by using the HTML code that is this, so script src and the URL to the library. So when a user navigates to your website and send a request, it will end up with this, your website page, and there will be this script. When the browser gets this, it will send a query to the jQuery server and gets the scripts from the external source. So this is nice and all. However, imagine there's an attacker that somehow hacked into this web server and changed the contents of the library to inject malicious code. So what would happen as a result? When the user sends the request to the website and it gets this answer, it will send a request to the server with that library, but because it was corrupted, it will get a corrupt version of the script. And depending on what the attacker has put into that script, it could be really bad for the user. So this ends up with a software integrity failure, as the website makes no checks against the third-party library to see if it has changed. So as a way to mitigate this problem, modern browsers allows us to specify a hash along the library's URL. So the library code is executed only when the hashes match. And this security mechanism is called sub-resource integrity. So sub-resource integrity, or SRI, is a new W3C specification that allows web developers to ensure that resources hosted on third-party servers have not been tampered with. And the use of SRI is recommended as a best practice whenever libraries are loaded from a third-party source. So we go from this script to this one. So it uses the integrity attribute, which will have the value of the hash for that script, and also using the cross-origin attribute with the value of anonymous. Here what is asked of us is to verify what is the SHA 255 hash for a certain script. And for that, we can go to srihash.org to generate hashes for any library if needed. So let's do that. So here it's asking us for SHA 256 for this script. And here we go. We can just copy this and have it here. So the next one is data integrity failures. If we think about how web applications maintain sessions, usually what happens is a user will log into an application using its credentials, and the server would send session tokens. Generally, this will be in the format of session cookies. So as you can see here, the session cookie will have the username or something. Then each time the user requests something, it will send the session cookie with it, and so that the server can respond with the right response. So this means that cookies are key value pairs that a web application will store on the user's browser, and that will be automatically repeated on each request to the website that issues them. However, if we take the example for this one where it was using the cookie with the username directly in it, it's a big problem. It's a big security problem because cookies are stored on the user's browser, so that means they can be easily tampered and changed. And so an attacker, can impersonate another user. So one solution is to use some integrity mechanism to guarantee that the cookie hasn't been altered by the user. And to avoid reinventing the wheel, we can use some token implementations that allows us to do this and provide proof of integrity. One of these implementation is JSON Web Tokens, or GWT. So GWTs are simple tokens that allows us to store key pair values on a token, and that provides us integrity as a part of the token. The idea is that we can generate tokens that we could give to users with the certainty that the users won't be able to alter the key value pair and pass the integrity check. So a GWT token is formed of 3 parts. The header, that contains metadata indicating that it is a JSON web token, and that the sign-in algorithm that is used is here HS256. Then there is the payload, which contains the key value pairs with the data that the web applications wants the client to store. And then the signature. So this is similar to a hash taken to verify the payload's integrity. So if we change the payload, the web application can verify that the signature won't match the payload and know that you tampered with the token. And this is because to compute the signature, the server uses also a secret key that only the server knows. And that's why you can't generate a new signature for that payload. Another thing that you have to know is the JSON Web Token uses just plain text encoded with base64. So the problem is a data integrity failure vulnerability was present on some libraries implementing the JSON Web Tokens. And we've talked about the fact that GWT implements a signature to validate the integrity of the payload data. However, the vulnerable libraries allowed attackers to bypass the signature validation by changing the algorithm. So the header section of the token, alg, to none, and then removing the signature part. So if we take the token from before as an example, and we wanted to change the payload so that the usernames becomes admin, and there is no signature check is done, and no signature check done, we would just change it to this. So we would change the header from HS 256 in the alg part to none, and the username to admin, and then we remove the signature. So let's test it directly. So the first question is, try logging into the application as guest, and what is the guest account password? So let's try something. Maybe I'm just gonna put whatever here. So we have this. So the credentials for the guest is guest. So we can add here guest. So if your login was successful, you should now have a GWT stored as a cookie in your browser. So let's press F12 and look at the storage, the storage in the developer tool to see the cookie. So here's the cookie. Now that we have the cookie, the next question is, what is the name of the website's cookie containing the GWT session? GWT token, sorry. It's called this. Now use the knowledge gained in this task to modify the GWT token so that the application thinks you are the user admin. So we know that here the application uses a GWT token, which means it's base64 encoding. The first thing we want to do is to decode the GWT token. So let's put it here. Okay, the last part is the signature. We don't need it. The only things that we want are these. So we want to change this. So let's copy this part, and then we want to change it. So changing the algorithm to none and guest to admin. So the problem here is we don't have that point. So what we need to do, I'm gonna remove that part using the text editor. Sorry. So this one is the first part. Then there should be a point, and there's this part. And here we go. So now that we have this, we can go back here and modify it. Now that we've modified it, we can reload it. And here you go. The next one that we'll be talking about is security logging and monitoring failures. So in the event of an incident, logging is here to help detect, escalate, and respond to active breaches. When setting up a web application, every performed action by the user should be logged. And logging is important because in the event of an incident, the attacker's activities can be traced, and once their actions are traced, the risk and impact can be determined. But without logging, there would be no way or no knowledge of the actions that were performed by the attacker, or if they gained access to particular web applications. So when logging and monitoring fails, they do fail, or insufficient logging, detection, monitoring, and active response, they occur anytime there are auditable events that are not logged, when warnings and errors generate no inadequate or unclear log messages, when logs of applications and APIs are not monitored for suspicious activity, when logs are only stored locally, when the appropriate alerting threshold and response escalation processes are not in place or effective, and if penetration testing and scans by dynamic application security testing, which are called DAST2 tools, do not trigger alerts. They should be triggering alerts. Or also when the application cannot detect, escalate, or alert for active attacks in real time or near real time. So the more significant impacts of these failures include regulatory damage. So if an attacker has gained access to personally identifiable user information and there is no record of this, final users are affected, and the application owners may be subject to fines or more severe actions depending on regulations. Risk of further attacks. So an attacker's presence may be undetected without logging, and this could allow an attacker to launch further attacks against web application owners by stealing credentials, attacking infrastructure, and much more. The information stored in logs should include the following information: HTTP status codes, timestamps, usernames, API endpoints or page locations, IP addresses. So these logs have some sensitive information, so it's important to ensure that they are stored securely and that multiple copies of these logs are stored at different locations. So what we can notice is logging is more important after a breach or an incident has occurred. The ideal case is to have monitoring in place to detect any suspicious activity. And the goal of detecting this suspicious activity is to either stop the attacker completely or reduce the impact they've made if their presence has been detected much later than anticipated. So common examples of suspicious activity include multiple unauthorized attempts for a particular action, for example, authentication attempts or access to unauthorized resources, requests from anomalous IP addresses or locations. So even though this can indicate that someone else is trying to access a particular user's account, it can also have a false positive rate. And this is if someone is vacationing somewhere or elsewhere, or someone is using a VPN or whatever. Use of automated tools. Particular automated tooling can be easily identifiable using the value of the user agent headers, for example, or the speed of the requests. All of these can indicate that an attacker is using an automating tool. And common payloads. So in web application, it's common for attacker to use known payloads. Detecting the use of these payloads can indicate the presence of someone conducting unauthorized or malicious testing on applications. The thing about all that is that just detecting suspicious activity isn't helpful. The suspicious activity needs to be rated according to the impact level. So, for example, certain actions will have higher impacts than others, and these higher impact actions need to be responded to sooner, and that's why they should raise alarms to get the relevant party's attention. So there are multiple mapped CWE for this. We'll see some of them, like insufficient logging to include, improper output neutralization for logs, omission of security relevant information, insertion of sensitive information into log file, and many others too. So for this practice, we are gonna download the tasks file. If you didn't do it, you can download it right now. So I'm opening the file, and what we can see, the first question is, what IP address is the attacker using? So what we can see here is all these 200, which are the HTTP status code, which means that they were successful login here. However, there are these that are 401 HTTP status code, which means they are unauthorized. So it was unsuccessful. And it's still in the login page. However, this IP address is the same for all four of them. So we can go directly to the answer. And add it. Next question is, what kind of attack is being carried out? So if you look at this, it's the same IP address, different login or different usernames. It's probably and the time is just, if you see here, it's just 5 seconds one after the other. It's 9 p.m. 9 p.m. But here we have 15 seconds, then 20, then 25, then 30. So it's probably brute forcing. And the last one on the OWASP top 10 list is server-side request forgery, or SSRF. So this type of vulnerability occurs when an attacker can coerce a web application into sending requests on their behalf to an arbitrary destinations while having control of the contents of the request itself. So SSRF vulnerabilities often arise from implementation where our web application needs to use third-party services. So for example, let's say we have a web application that uses an external API to send SMS notifications to its clients. So for each email, the website needs to make a web request. And then, so this sends a request to the web server, and then the web server will build the query to send it to the SMS provider's server to send the content of the message to be sent. And since the SMS provider charges per message, they require to add a secret key, which they pre-assign. And this secret key is the API key. So the API key serves as an authentication token and allows the provider to know to whom to bill each message. So if you look back at the URL that was sent here, we see that the server, the application exposes the server parameter to the users, which then defines the server name of the SMS service provider. So if an attacker wanted, they would simply change the server value to point to a machine they control. So the request would change first, and then when it gets to the web server, it changed the query. So once the server built the query, it sent the new query to the attacker server, allowing the attacker to obtain the API key, and then the attacker would be able to use this API key to use the SMS service to send messages at the expense of the website, the emailing website. So in this case, we only need to capture the contents of the request using netcat. We could do that like this, and so we'd end up with this. So the consequences of an SSRF depends on the specific scenario. And an SSRF can be used to enumerate internal networks, including IP addresses and ports, abuse trust relationships between servers and gain access to normally restricted services, and interact with some non-HTTP services to get more remote code execution. For SSRF, there is only one mapped CWE. It's the CWE 918, which is server-side request forgery. But we never know what will happen in the future. So let's take the knowledge that we got right now to practice. So the first question is, explore the website that is, and what is the only host allowed to access the admin area. So let's look here. There's the admin area, and it says only available from localhost. Okay, nice. Then check the download resume button. Where does the server parameter point to? Okay, here I need this. So let's go back here and wait a second. We can, if you look at the link on in the bottom, we see that server equals secure file storage, but we can just copy the link and have it here. So it goes here, goes to this. But it's asking for everything but the port. So using SSRF, make the application send the request to your attack box instead of the secure file storage. Are there any API keys in the intercepted request? So what we've seen here just before is this, we should have to change it to our own server, to our own IP address. So before doing that, I need netcat. So I'm just gonna put NC, so netcat, L for listening, V for being verbose, N for not resolving IP addresses into names, P for port, and here we are listening on port 8087. So now that it's done, this is my IP address, my VPN IP address. I'm just changing this to that IP address. And now let's see. Here we go. As you can see, there's the API key. So another thing you could do, there's a way to use SSRF to gain access to the site's admin area. Can you find it? You could do it if you want to, but that will be it for me. So thank you for watching. I hope you enjoyed this video. It was the last part of the OWASP top 10. You'll be able to find all resources in the description box, and have a good day. Until next time. Bye.